Welcome. This is Ikigai Dev Milestone 12. In this release cycle, the primary work that we have done is on a remote control harness to drive Ikigai. The reason for this is that Ikigai is a TUI application, and that makes it kind of hard for external processes to drive it. With a normal terminal application, you would just run the process and attach to standard in, standard out, but that isn't an available path here because Ikigai is going to switch into alternate buffer mode, which requires it to have a TTY available, which isn't when you run it as a sub-process normally. And while in alternate buffer mode, there is no standard out. So that further complicates things. And this has made debugging Ikigai fairly difficult at times. And so in this cycle, what I've done is that I've added in kind of a remote control process. And the way this works is Ikigai is normally sitting in a select loop and it's watching the keyboard. And what we've done is tied in input from listening to a Unix socket. And so now external processes can connect on that external socket and send keystrokes and make requests to see the frame buffer and things like that. And so I think that the easiest way to do this is to kind of demonstrate it here. So we want to load the end-to-end testing skill. And then I'm going to tell it that Ikigai is already running. Use the Ikigai CTL. That Ikigai CTL is both a skill and a script. Here I'm telling it to use that skill, I guess. Use the Ikigai CTL to what's happening here, of course, is the LLM on this side, right, is going to make tool uses, bash tool uses to use the Ikigai CTL. The Ikigai CTL allows it to send keystrokes and then read back the frame buffer. And so let's see if it just tells us what was returned. Oh, see, yeah, there it's reading the frame buffer. And it should let us know what was, there we go. So the idea behind this is really, really straightforward. This is going to become our black box outside in testing, right? And once this was working, then the next step was to build out a set of tests. And what I'm going to do is say, run just the Gemini E2E tests. I'm going to limit it, in fact, run just the first three Gemini and end-to-end tests. So now at the moment, I think we have about 30 end-to-end tests, and they're really, really basic. The set of tests that I built out first was simply to change to every model and verify that you could chat with the LLM. So all it's going to do is for each of these three models is it'll switch over, it'll say hello, it'll wait for a response, and that will constitute a successful test. So we'll watch this run through here real quick. It isn't super fast doing it this way, but this will build on layers, right? And so the very first thing was I wanted a set of tests that the LLM or I could drive and verify that they actually worked when connecting to the actual provider. So these are burning tokens on both sides. We're burning tokens to figure out how to connect and do the input to Ikigai, and Ikigai is burning tokens to go out and talk to an LLM. But that outside layer ensures that actually everything works and all of Ikigai is being used. And the only part of it that's not being tested here is the is essentially the input buffer because we're pulling from the Unix socket instead of the keyboard. And then on the other end of Ikigai, all of it's being used, and the only part, well, right now it's actually running, and we're using it, and you can see it. But we also added a headless flag so that it could be run in the background. And when we run it in the background, the only part that's missing is the actual buffer copy. And so, like 99.9% of the code is exercised from one end to the other through this mechanism. Is literally is inputting single keystrokes, so we'll be able to troubleshoot the edit input, and things like tab completion and all of that will still work because it's literally raw keystrokes being pushed in. Okay, so the tests can be exercised like this, but they can also be. I'm going to have to start the two pieces here. So. The first part is we have a replacement for the providers. So that is bin mock provider. Okay, so we have this mock provider running on port 9100 here, and what it's going to do is it is a replacement for the providers that Ikigai is connecting to. And so let me see if I can cat tests end to end and serve. And so you can see here what we've done is when I run this, we're going to launch Ikigai, but we're setting environment variables to override the URL that's being used to connect to the individual AI providers. And so let me run that. And the only thing that's different here is that we're not talking to the real providers anymore. Everything else is still complete. So now what I want to do is I'm going to ask it to and you'll see that the responses look more canned, and that's because it's actually, it is the mock responses that we've set up for these tests. I'll show you the tests here in just a minute. You can see the script for the test. This isn't the fastest thing, but it gives a really high level of confidence because I can run it against the actual providers complete. I can then run it against the mock provider. This is a more common way to run it. I don't have to spend tokens on both sides. Or I spend less tokens. And then eventually here, after this, I will show you the complete runner with mocked input and output. And so you can see here mock response from 01, right? I mean, these are just the canned responses that we build for the mocks. So, we're not actually going out and talking to the LLM here. So we'll let it run through these three tests. If I'm doing a large set of these, I can actually, if you let Claude build up a kind of script part of this, it actually can run pretty fast, but it's not doing it when I'm just asking it to run for three tests here. What I found I did a little bit while I was working on the model and providers improvements that we did is that I could work with Claude interactively to develop the code and have it test and watch what was going on. It was a much nicer process than in the past where I had to do it 100% through logs. Because AI could see it at the same time that Claude could see it. It's seen the same thing that I did because it could read the buffer. And so whereas before with the log approach, often it could read the events that happened in the log, but it wouldn't know the representation that I was seeing on the screen. And so I would end up doing copy and paste, trying to capture stuff from the screen. It was a lot more awkward. This is clearly just a lot better. So this should be the last test, I think, here. There we go. And now, so that is, the first demonstration was everything was live. In this demonstration, Ikigai is connecting to a mock provider. The last thing I want to demonstrate here is that there is also let's see, it's in tests, E2E runner, and I need to give it a directory full of tests. So that's the same directory. Now in this case, what it's doing is it's reading the, it's going to run through every test. It is playing the script into Ikigai, and Ikigai, it has the mock provider. So we're not using tokens on either end, because this is a script, not an LLM pushing in the input. And it is the mock provider doing the return. So there is no token burn while doing this test. It's the exact same set of tests. And you can kind of see it's walking through. In fact, the very first ones, or the very first OpenAI ones, were the ones at the top of the list here, right? You can see that it says hello, and then it gets that same mock response back. And you can kind of see how we have this broken up here. So like, here it's just announcing this is this particular test file. We're going to send these keys. We wait for a half a second, send more keys, wait. Where you see wait idle, that is just waiting for, that's where we wait for the response. Remember, it's the same test file, no matter which mechanism we're using it through here. So like on the LLM side, we don't have any idea how long, when we're actually burning live tokens on all sides, we don't have any idea how long it's going to take for the LLM to respond. So what we do is we just wait for Ikigai to go idle again, meaning it's got its response and it's waiting for input. And here we're saying, well, we'll wait to go idle 15 seconds. And you can see it reads the frame buffer, and then it makes a bunch of asserts off of the content in the frame buffer. It's really all that it is. So you can see that it ran the 31 tests, 124 assertions, 124 passed. And if I look in, so let's do tests, E2E tests, and then look at, we'll just look at whatever. So here's the Gemini Pro test, and it's much like you just seen in the output of the runner. The runner is basically just telling us as it's working through each of these steps. Now, the part that is named a little funny here, this is the part that puts the response into, so like, we're going to say hello, and we're expecting the LLM to make a response. This is the thing that inserts into the mock provider the response that it will give, right? So, and you'll see that it actually takes an array, and we can push in like a series of tool calls or whatever we want, followed by an eventual chat response. So far, I haven't run into enemy. I mean, we'll expand it if we do, but so far, I think that the implementation is complete for what we need. The reason that the assert mock is called out separate, this is the part that verifies that we actually got the response. The reason that that's called out separate is because when we're running in live mode, you wouldn't get that exact response, so you're not checking for it. Instead, what we're doing, in some ways, this is kind of redundant. I could just remove it. Instead, in live mode, what we're doing is we're looking to see that we eventually got a chat response. We don't have it here. Let me see. I want to see if we have it in. So here, yeah. So these line prefix ones are kind of our cheats right now. What that's saying is, this is the prefix that would always be there if we're getting a tool request, and this is the prefix for a tool response. And what I expect when we make this prompt is that it's going to give one tool request, one tool response, and that we're going to have a chat response from the LM. I might improve the language that we're using here. This might turn into a little bit nicer testing language, but it works really well, even if not entirely obvious reading through it there. Okay. The other thing that was done in this release, well, we did the end-to-end testing. That's what we were just talking about. We went through the models. Once I had the end-to-end testing working, I could actually, we have, I don't know the exact number. It's right around 30. I shouldn't have done that. So it's right around 30. And what's kind of unique here is that all of the providers have more than one layer of. I started working on this right when we were kind of at that transition between non-thinking models and thinking models, and now we're kind of falling into the second generation of thinking models. And so each of the providers has multiple layers of their API, and it keeps evolving. And what does it say here? We have exactly 30. And so the fact of supporting 30 models was I wasn't really able to manually test all of those in kind of a live black box mode. And I did discover some discrepancies where, for example, um, in the GPT, in some of the GPT-5 models, I forget which ones, for example, you can only set a thinking level of medium. It doesn't matter. There's no other value allowed. You set medium, right? And I missed that in one of the providers, and we were trying to set it like in the other efforts. In fact, I'm going to demonstrate this a little bit. I want to show it here. So let's. So if I clear this and I say model, you see, we'll do Claude, Opus 4.6 high. And you can see here, we made this a little bit more uniform. So this value here is what I just asked for, high. That's our internal representation. And what it's actually setting is the adaptive high value for that particular model. So, I mean, that's how its API refers to this setting, as we're using the adaptive mode, and it's in high effort, high thinking. And then let's just do model GPT 5 low. And you can see here that it uses something called effort, and it does use the actual value low. And then let me do model. Let's do Gemini 2.5 Flash. Let's go medium. And you can see that this one uses a token budget, and it's set at 16K for medium. And so there are a number of different systems behind the hood here. And what we do is, in fact, I guess I should call this out too. We have, let's do, which one do I want to do? So let's do model Claude IQ 4-5, none. Interesting. None is not a value anymore. I didn't mean to make that mistake, but this was what I was trying to demonstrate. I termed it. We used to have none, low, medium, high. We now have minimum, low, medium, high. And I made that change because, so model IQ 4-5 to min. I made that change because in this particular example, you can see it set a budget of 1K. And that's because that particular model doesn't actually support a none. Some do, some don't. And so the phrasing is just better to call it minimum. It's whatever the smallest amount is. One of the Gemini models, for example, only supports like 256 tokens as its smallest thinking level. And so it would use 0 if that is the smallest possible value, or it uses the smallest value. Otherwise, I mean, in fact, the way it's done is it's pinned. Smallest possible value, highest possible value. And then we aim for 1/3 and 2/3 for the minimum and low, whatever the scale is. And if there's a gap, like if there's an uneven gap, I put it between medium and high. And the reason for that is usually by the time you're going high, you want all the thinking. And if you're kind of incrementally stepping up, you're still being conservative. And so I decided if there was going to be an uneven gap, it would be between medium and high. That is pretty much it, I think. Actually, let's just do a scan through this just to make sure. So, we did the control socket in headless mode. some documentation around it, some code quality changes. The frame buffer serializer it actually is returning a JSON representation of the frame buffer. The frame buffer is printable characters, but it has all the ANSI escape codes with it. And so we return them as literally the a printable representation. It's got to go into JSON anyway, and it's not a real particular performance issue. I think by default I have it running with a something like a 50 by 100 terminal, so that there's enough room on the screen for it to capture stuff. That really was the entire release. I am very much looking forward to kind of the improved testing harness here. In fact, so much so that I am planning, now that I have this, and over time it will start to extend and it'll cover like all of the functionality. I am going to start to tear down some of the existing tests and then like rethink them. The I they just there's room for improvement in them, and so having this black box testing, even though it's a little bit slow, will give me the confidence that I can tear the other parts down. I will know if we're breaking something, and then start to rebuild those things. I think that is pretty much all of what is this? It's milestone 12. So in the next release, the focus is going to be on more testing improvements, but probably also a large amount of work is going to go into the Ralph pipeline stuff. That's where I'm at with this. Is here, let's actually I'll do it in here. If we look at project README, so the next big feature I'm calling out is probably the work on the sliding context window. Realistically, these next two could come in either order. Parallel tool execution is a big deal right now. Probably the biggest thing that keeps me from using Ikigai on a daily basis is just user experience. It's not as polished. So little things in Claude Code that I need to add in, like being able to enter text while you can't. So this may not. So get it to think for a little bit longer. So what you'll notice is, while it's thinking, you notice how the edit area is completely collapsed. I can't enter anything. But on the other hand, if I do that on this side, I can type right now. So that is a significant small usability feature that probably prevents me from actually using Ikigai on a daily basis. It's little things like that. And then maybe the two remaining, the sliding context window isn't the thing that prevents me from using it, because I am so used to clearing and rewinding with Claude Code that I'm not missing anything here. I'm so used to doing that. But the parallel tool execution not having it does slow things down a little bit. So that is probably, there is a good chance that I'll end up swapping these two in order. But this next week, I'm still kind of focused on speeding up the entire development process. And so I have been reworking the Ralph harness, and a whole bunch of work will go into that, and then I will kind of show that off next week. Anyway, that is Ikigai Release 12. Thank you. I will see you guys all next time.